So it's a handy little tool. There's a slightly different category of tools, which are what I call incident capture. The things I was just mentioning are for, I want to look at the server live, and I want to see what's going on. Sometimes, though, what you want to do is you want to log the low-level information about the server, so you can go back later and try to line it up with when bad things happen in Postgres logs. You can run top in what it calls batch mode, and it will write data out like that. It's kind of a pain to deal with, but it's there. There's the other old school Unix utilities. There's a program called NoHop, which is good to know about. If you run NoHop in something, you can leave something running after you disconnect from the server. It kind of turns it into a mini daemon, and whatever output it produces will get sent to a NoHop log file. A lot of times, if I'm doing maintenance operations, vacuums or rebuild, index rebuilds or stuff like that, I'll create a script that does the work, and then I'll execute the script using NoHop for that. Some people prefer to use the screen command for this type of thing instead. The main advantage of NoHop is that it will be available in a lot of environments that script is not. Script is the final one in this kind of trio. If you run script, you'll end up with everything else that happens in that session from that point forward is now written to the file, including the keystrokes and everything. So if you want to record something happening, and you can get that something happening to show up, and you run script and run it, you'll get a log of that whole thing that happened later. So I will sometimes, if I see, wait a minute, something bad is going on with the server, and I want to investigate it, I try to remember to run script first, and then if I'm doing things like looking at logs and activity and stuff like that, and I want to go back later and review that more, I don't have to go capture it from scroll back or whatnot. I've already got a log that I can have it. So these are some handy little tools. If you're using Postgres, you may discover you really want to come up with new things that you necessarily may have ever wanted to do. So we talked about locking. In order to really figure out what's going on with locking on your server, you need to combine information that's available in PG logs with information that's available in PG stat activity. These are both live views. Each of them has pieces of what you want to know. The wiki has a couple of different example queries that combine this data a few ways. There's some examples in my book as well that do more complicated things. I highly recommend, again, doing this with your servers lightly loaded to get an idea of what's going on. A lot of times people are really surprised by the order in which locks get acquired. It's like, wait, that locks that? I was completely not expecting it. So it's good to get familiar with this sort of thing as early as you can, because if you don't know what it looks like in an easy case, it's difficult to distinguish, wait, is this screwed up, or does it always acquire locks like this? Trying to sort that sort of data out is hard to do once the server is really busy. It's a lot better if you can run some tests and simulate things on a smaller system without that many things, and become familiar and get your own little toolkit that you're comfortable with that works the way you want for analyzing this data. Put that together, because eventually you're not going to get anything that comes with Postgres. You may very well run into these spots and do something else. Database monitoring. I mentioned these two already. I mentioned TopC. There's also another utility called PG_top floating around. The PG_top is another one of these things that you can add in. It actually shows the full text of the query along with the information about CPU it's using and stuff like that. If you're looking for something that's more like an interactive database dashboard kind of thing, what's the server actually doing at the moment, it's probably the closest thing to that you can just compile and run it and go with from there. So these things are all kind of handy, but for me, real-time views are great, but what I really spend a lot more time doing is capturing stuff in a way that I can do something like long-term. An additional component to this is alerting. So there's monitoring, in my mind, is alerting plus real-time data plus trending, which which is historical stuff. Alerting, I'll just mention briefly here, because the trending stuff's a little bit. If your server runs out of disk space, it's going to crash, and it's not going to be pretty to recover from. You really want to watch for that. The most common way that I see servers in Postgres run out of disk space is it's a pretty good performance practice to put the write-ahead logs for the server on another drive. That drive tends to be smaller than the rest of them. If you're using Postgres's replication to make a copy of your database, it's possible that that write-ahead log space will fill if something happens with the backup server. And so you can actually have the primary server say, under no circumstances am I going to proceed until I've sent this data, until I've archived it in the archive in the backup server. You can set that up in a way that when the backup server, what Postgres calls a standby, runs out of space, the main server runs out of space eventually too, and then the main server goes down because of a problem with standby. So you really need to check this stuff on the standby servers as well as the backup, as well as the main one and any backup servers that you're doing. It's very easy for write-ahead log stuff to get out of control and crash because it's using a ton of disk space for things. You may be surprised at how big the write-ahead logs are relative to your database. There's a program called Nagios, sort of the standard open source utility for this stuff floating around that monitors things. It's not great, but it works, and it's integrated with pagers and all sorts of other stuff. There's a utility called Check Postgres. It's the standard one to integrate in with Nagios. It includes lots of checks, even for, it even makes a guess at complicated things like table load. It tries to estimate that. It's not super accurate or great, but it at least gives you a trend line to follow if you look at it. You can use Check Postgres in other alerting systems, and what I do recommend to people is even if you're not using Nagios, even if you're not using Check Postgres, look at Check Postgres anyway, because the information that Check Postgres is looking at and that it saves is information that's been proven to be useful data to look at to keep your Postgres instance running. So sometimes you can look at it and go, well, I can't use this tool, but that's a neat idea for monitoring. Let me go build something that monitors that same way that monitors it. So I would, and a lot of the queries that it runs are actually just non-trivial SQL, and so you don't get the source code to them and then over to something else. So definitely take a look at that if you haven't already, even if you know you're never going to use it. Use it for mining for ideas. Trends. Trending is the last component of monitoring. Trends matter a lot. This is an honest-to-God customer database. We reinstalled their server at the end of January because they've been running into performance problems. And they said to me the other day, hey, how come our server is not responding to queries in all circumstances in under a second anymore? And I told them, well, that's because your database has doubled in the last 4 months. This is what the beginning of infamous exponential growth looks like on an app. You start seeing stuff like this, it doesn't matter how much you do or how much you do. If you're growing like this, you're gonna suffer some problems. And stuff like this is why you want to get these graphs and get them all lined up in line. If I didn't have this historical context, when I got asked the question, why are things so much slower than they were when they migrated to the server in the end of January, I may not have had a good answer to it. Now it's, oh, well look, there you go. The database is twice as big. It's really hard to put as much data in this anymore. And it's got to process more rows for every answer's query. So, there's usually a big discontinuity for people when the server no longer fits in RAM. It gets a lot harder to tune than when everything fit in RAM. You can be much sloppier on things. So this server has 64 gigabytes of RAM in it. As you can see, you can almost project out exactly when this thing is going to start running into those performance problems. And being able to see the size crossed RAM idea what's going on. And a lot of performance tuning is just assigning cause and fact and getting the right relationships between things. And sometimes the cause is just there's more data to go through. It's going to take longer to do. So what